This video looks at the last section in the alkanes topic. We're going to look at substitution reactions of alkanes using chlorine and bromine. There are a few definitions that you need to learn. A radical is a particle with an unpaired electron. Homolytic fission is bond breaking, in which one of the shared electrons go to each atom. And heterolytic fission is when bond breaking, both electrons in a shared pair go to a single atom. In this mechanism, we will be looking at homolytic fission. There are two ways to split a covalent bond. Usually we see uneven splitting, and that's where both of the electrons go to one of the atoms and produces ions. However, in this reaction, we are going to see equal splitting, where one electron goes to each atom and we form radicals. This is known as homolytic fission. We are going to study the reaction between chlorine and methane. In this reaction, a chlorine atom is substituted for a hydrogen atom in the methane molecule. The equation for the reaction is given on the slide. This is a photochemical reaction in that it occurs only with UV light. In the reaction mixture, you will get chloromethane, but you will also get other products. Now we're going to look at how this reaction occurs, and that is referred to as the mechanism. There are three stages in this mechanism. The first is the initiation stage, when the chlorine molecule breaks up to form a chlorine radical, and you form two chlorine radicals, the equation given on the slide. The dot signifies a radical and an unpaired electron. The propagation step is where we take the starting material, which is methane, and we react it with the radical. In this case, it pulls a hydrogen atom away from the methane and produces a methyl radical. And in the second stage of propagation, the methyl radical reacts with chlorine to produce chloromethane, which is your product, and another radical. If you look at both of these equations, you will see a radical on the left-hand side and a radical on the right-hand side. So radicals are being used up and regenerated. This is why we call this step propagation. The final step is termination, when two radicals come together to form a molecule. The most common equation being the two chlorine radicals coming together to form a chlorine molecule. In the reaction mixture of methane and chlorine, we find some ethane, and this can be explained because two methyl radicals can come together to form ethane. This slide shows the overall equation for this reaction and also equations for the initiation, the propagation, and the termination. However, we may not only get chloromethane in our reaction mixture. The reason for this is the chloromethane produced can actually re-enter the propagation steps and form dichloromethane. The dichloromethane can enter the propagation steps and form trichloromethane, and the trichloromethane can enter the propagation steps and form tetrachloromethane. We can try and limit this by using a large excess of methane, and our major product then would be chloromethane. Here are some tips to help you remember how to write the different steps in the free radical substitution. The initiation step is when you take the halogen molecule and you form two halogen radicals. The propagation step is when you start with the alkane and you use your radical, you form an alkyl radical and hydrogen halide. The alkyl radical then enters the second propagation step and reacts with a halogen molecule to form your product and another halogen radical. And your termination step is just two radicals coming together to form the molecule. This helps if you have to write initiation, propagation, and termination steps. You might want to pause the video now and try and write the initiation, propagation, and termination steps for the reaction of chlorine and ethane. The first step is, of course, the initiation reaction forming the chlorine radicals. In our propagation step, we start with ethane and we form an ethyl radical, and the ethyl radical reacts with the chlorine molecule in the second step to form chloromethane, ethane, which is our product. Our termination steps could be any of the following equations. You can see that you may even get some butane in your reaction mixture where two ethyl radicals come together.